We will discuss the second one first. So calculate the resonance energy of isoprene from the data given. Isoprene is going to be given as something which has formula as C5H8.
Cyclo.
Not necessarily cyclo. Do not assume cyclo.
Okay.
Now, standard heats of combustion of isoprene, carbon and hydrogen are given here. So they're giving it to you as heats of combustion. So C5H8 plus O2. Whenever you're given data, what is your first job? Put them down.
Balance.
Put them down properly. Put them down equation form wise.
Yeah, that's
So standard heat of combustion now for combustion means it's defined for what? For 1 mole of the substance.
CO2. Complete.
Put 1 mole of this guy being burnt. I'm going to be getting complete combustion products as of course carbon dioxide and water. So how many moles of carbon
5
dioxide?
carbon should be there.
Water?
Water 4. Yes, 4.
Right. So we're going to be having
this
5,
side, 10 this side, 7. Yeah.
This is the equation.
Yes. Yeah.
Next up, they are giving standard heat of combustion of carbon. Carbon being burnt, 1 mole being burnt is basically
1 mole of CO2.
the formation of carbon dioxide. That is, we can write it as enthalpy of combustion of carbon is the same as enthalpy of formation of carbon dioxide.
Yeah. Oh, correct.
Yes or no?
Yes.
Same way for hydrogen. H2 plus O2 giving H2O. Like, right? Enthalpy of combustion
is equal to formation of H2.
Hydrogen gas is same as enthalpy of formation of what?
H2.
Water.
Is equal to sigma bond. Okay.
Correct?
Yeah.
Now, they are giving us bond energies of C double bond C, C single bond C, C single bond H, and H single bond H. And they are giving standard heat of sublimation of graphite.
Yeah.
Okay. Now, let us now try to see how to basically get this done here. So this is going to be heat of sublimation of graphite is given to us, and they are giving us H single bond H bond also.
Yes.
Okay. So now let us try to see how to form C5H8. If I have to form C5H8, let's look at what should be C5H8 roughly. If it is C5, what is the general molecular formula telling you it should have if it is fully saturated?
6 minus 1 ring, 1 double bond, 2 double bonds, 2 ring.
2n plus 2 Cn H2n plus 2 is full saturated.
Yes.
So it should have been C5H12.
Yeah.
Instead of 12, I'm having it as what? 12 minus 4.
Okay.
Correct?
Yeah.
So double bond equivalent is how much?
It's 4, 2. So 2.
2.
C plus.
So I do not know what is present, whether it's a double bond or a triple bond, but I can guess how many double bonds should be there.
Yeah.
2 double bonds should be there.
2 pi bond.
All should be single bonds over here, correct?
Yes, sir. Yeah.
So C5H8 or isoprene.
2 moles of H2.
So should be having 2 C double bond C.
Yeah.
Correct. So let me randomly draw one possible structure and see what is the scenario there.
Okay, so we need to break 2 pi bonds.
So this is going to be the expected formula here, which will look like this. CH3 of these, 1 hydrogen, 1 hydrogen, 1 hydrogen, and 2 of them. Correct? 1, 2, 3, 4, 5, 6, 7, 8.
Yeah.
This could be it.
Or a triple bond. Yeah.
No, it doesn't matter what it is. They have given me only for double bonds here. Or they may be in 1 and 5. Instead of 1 and 4, 1 and 3, now it can be 1 and 4.
Yes. Right.
Correct? Huh?
Yes.
I can put it at 1 and, or it can be some other form.
Anything. Yeah.
The methyl could be somewhere else. I don't know where it is. Right? So if it is of this kind over here, it is going to be having what bonds present here? The number of bonds present will be remaining the same as long as double bond equivalent is same. Correct?
Yeah.
So I can say 2 carbon double bond. How many carbon single bonds are there?
Carbon single bond. 5.
Double bond na C double bond C together.
Oh, so we're not. Okay, man. Then 2.
2. Then how many other bonds are there? 8
Hydro-
carbon sigma
CH.
bond hydrogen.
Yes, sir. That's
Correct?
it. Yeah.
These are the bonds which are formed when you're forming 1 mole of isoprene. Correct?
Yeah.
So now let's write an enthalpy of formation of isoprene. I'm going to be having carbon solid plus hydrogen gas, giving me C5H8. Correct? 1 mole of this fellow.
Yeah.
Let's not bother with what physical state this guy is. Let's assume it's formed whatever. So what are the processes I should be doing here? I should first convert the carbon solid into carbon graphite.
Okay.
And I should break the hydrogen
Break the hydrogen
into hydrogen atoms.
So should we balances?
We will balance, but
Okay.
let's look at the process, then we'll combine them all. So first, 1 mole
Breaking
of
of bonds.
to be 5 carbon and 4.
Yeah.
So 5 moles of carbon solid should have been made into 5 moles of carbon gas.
Yeah. 4 moles of H2, 8 moles of
molecule should have been made into 8 moles of hydrogen atoms.
H. Now we should combine them.
Now we should combine these guys and get here.
Okay. Yes, yeah.
Now this process is going to be sublimation.
Yeah, the 5 into the given.
And this is something where I am breaking what? H single bond H.
4.
Correct?
Yes, sir.
And what am I forming here?
2 sigma, 2 CC. Yeah.
2 C double bond C,
2
C single bond C, and 8 C single bond H. Now they have given us values for this.
What are they asking?
They're asking resonance energy, if any, for C5H8.
Okay.
So you need to calculate this enthalpy of
Subtract
formation.
But no.
Calm down. Pay attention here. In this here, you can calculate enthalpy of formation now. How is that going to be? First, I need to take this process.
Reactant minus product.
The value for this? Can you calculate the value for this?
Yeah.
Done. This, can you calculate the value?
Yes. Yes.
Done.
Subtract.
This is given.
Yes.
This is given. This is given. That means I can find this out.
Yes.
By adding and subtracting. So let's substitute the values and check out ki kya aa raha hai. Let me just simply put the values over here. Sublimation of graphite is given as 718.3. So this is 5 times 718.3.
Yeah.
So let's put down the numbers. So delta H formation of C5H8 is going to be 5 into 718.3.
That's 4 into.
No, stop. Don't do that. That is for a calculator to be done later. Now next, what is going to be the next thing? 4 into, sorry, you're doing that only. I'm sorry. Sorry. 4 into what?
4 into HH. 438.8. 435.8, my bad.
So it's going to be plus 4 into 435.8.
Subtracted by.
Next.
2 into C double 1 C.
2 into 615.
Plus.
So minus 2 into 615.
Minus again 2 into 413. No.
348.
348.
So very important. You have to take those data out carefully and put them down.
Yeah.
Minus
8
8.
into.
Don't have the book over here, so yeah, fair enough. CH.
Third one. 413.
413.
104.7.
This is going to be an enthalpy of formation of C5H8 expected.
Yeah. But they gave the value.
Expected, no resonance.
Yeah.
Correct?
Yes, yeah.
Now, you can calculate enthalpy of formation of C5H8 using this also. In this approach here, how do you calculate here? You have been given enthalpy of combustion of this. I mean, enthalpy of formation of this, enthalpy of formation of this.
Yes.
Right? You have been given enthalpy of combustion of this.
We can get it from this route.
right?
Yeah.
So calculate enthalpy of formation from this.
Subtract by
So
this.
we can write it as enthalpy of combustion of C5H8 is equal to formation of products minus reactants, correct?
Hmm.
What are the products form? 5 moles of CO2, 4 moles of H2O.
Yeah.
So it is going to be 5 into enthalpy of formation of CO2 plus 4 into enthalpy of formation of H2O minus 1 reactants. I have to subtract enthalpy of formation, correct?
Hmm.
This is something which I do not know as of now, so I'll put it as enthalpy of formation of that guy. This is how much enthalpy of formation?
7 into the we
Oxygen,
have
normal elemental form already, so 0.
0. Yeah.
So minus 1 into enthalpy of formation of C5H8. This is enthalpy of formation actual,
Yeah.
including resonance.
We have this value. Yes. Now we can calculate.
So with the resonance.
Okay.
You understand the idea now? So you calculate this value from here and you compare it with this value which you have calculated here. The difference between them will give you your resonance.
Yeah. Okay. Understood. So, yeah.
You understand this type of a question?
Yes.
This is a typical good question, which you can expect as what to say, a middle level or an easy level JEE advanced question. I would call it a stage category 1 or category 2 JEE advanced question. Which it is not exactly category 1, but it's a category 2 JEE advanced question. Where you have some time, and if you have practiced this kind of a question before, you can definitely try it out and get it correct if you are patiently doing it. It doesn't involve too much thinking, so you can say it's category 2, category 3. Not really beyond that.
Yeah.
It doesn't require special level thinking and shit. It requires regular thinking. You understood this question properly?
Yes, sir.
Now, we'll close the session here. You think on this thing for yourself.
Yes, sir.
This is something which is going to be requiring a new equation. You think.
Okay. Wait, so we cannot do it without the equation?
No, you can.
Okay.
Can.
Okay.
You can derive the equation and do the same thing. It's not that complicated of an equation. It's a fairly straightforward shit only. So
Okay.
it's not going to be that complicated. You have to understand though a little bit more. Let's see where you come. So
Okay.
you have done physics. So this will test how well you understood physics.
Okay.
Okay. So I'll quickly describe what we are trying to do here. We are given the enthalpy change. We are given the enthalpy change for this reaction. Given delta H naught for the reaction at 298 Kelvin. Asked to find delta H of the reaction at 773 Kelvin. So all the substances, the reactants products, all of them are scaling up in temperature. All of them are gases, and it's all done at constant pressure.
Yeah.
That's the hint I'll give you. You have been given the CP values for each of them.
Okay.
Okay.
Yeah.
All right. I will close the session here. I'll see you sometime tomorrow or day after. Practice some more. And thermodynamics, please sit and practice enthalpy related questions. I did not ask you to sit and do work done. Okay. Sit and practice enthalpy related shit, because you have discussed a bunch of enthalpy related shit already. Please start practicing enthalpy related questions. They are going to be very critical. That is where your chemistry questions will come from. Mainly. Not from Carnot and shit.
Okay.
Carnot and crap.
I skip that.
That's all physics crap. Don't go there. Work done, if they're asking for irreversible processes, yes, that's chemistry. If they're doing reversible only, that's the same as physics.
Okay. Yeah.
All right, let's close it here today.
Yes,
I'll see you some other time next time. Bye-bye.
So yeah, thank you, sir. Have a nice day.
Have a nice day. Bye-bye.